Okay, so what I want to look at today is congruent triangles. So let's write down exactly what congruent triangles are, and you do need to know this word. Congruent triangles are identical triangles. So congruent triangles are identical triangles, like twins. All of their angles are the same size. Same size, and all of their sides are the same length. So everything about them is the same. They might have a different rotation, and they might be in different places in space. Messy writing there. We have 4 ways of telling if triangles are congruent or not. So they don't usually give us all the angles and all the sides to tell whether triangles are congruent or not. But we have these 4 rules, and we can remember them by the letters that we use. So SSS. If all 3 sides are the same, if all 3 sides are equal, that's sufficient. All 3 sides are equal, then 2 triangles are congruent. A picture to go with that. So it doesn't matter how they're rotated, but if this side and this side are equal, and this side and this side are equal, and this side and this side are equal, then we know that all their angles are equal as well. So, excuse me, if all 3 sides are equal, then the triangles are congruent. The next one we have is SAS, side, angle, side. So what we say here is that if 2 sides and the angle between them and that's really important, the angle in SAS must be between the 2 sides that we're talking about. Excuse me. If 2 sides and the angle between them are equal, then triangles are congruent. So if I have a triangle like this, and I have an angle here that we'll call A, different length sides there, and I might rotate things, but I have the same angle A here and the same lengths of the sides, then these triangles must be congruent by SAS, side, angle between, and side. Okay, this would not work if we were told a different angle being equal. So let's just put down a note about that. If I had a triangle like this and an angle down here, so something like this, I can't say, they might be congruent, but I can't say these are congruent as the angle isn't in between. Sorry, I went off the page there. So these guys here, I have 2 sides the same and I have an angle the same, but because it's not between the 2 sides, I can't say that they're congruent. They might be, but I don't know. Right, the third way we can tell that two triangles are congruent is our ASA rule, angle, side, angle. This time it's two angles and the side joining them. So if two angles and the side joining them are equal, then the triangles are congruent. So again, if the side that's equal is not joining the triangles, then we can't say that they're congruent. So I might have a triangle like this, the angle A and the angle B, and the side joining them. Maybe a different rotation of it. Say the angle A, the angle B, and the side joining them. So then those two triangles are congruent. Everything about them must be identical. If we were told those two angles are the same, but one of the other sides were the same, we can't say that they're congruent. And the fourth and final way that we check for congruency is with right-angled triangles that have a hypotenuse the same and one side the same. And this is obviously true because if the hypotenuse and a side are the same, we'd calculate the third side must be the same as well. So this reduces down to SSS, but we do use it without doing the calculation. So if you have two right-angled triangles with equal hypotenuse and one other side the same, then those triangles are congruent. So if I have a right-angled triangle like this, I don't need to know the third side so long as the hypotenuse are the same and one of the sides is the same, they must be congruent. Now, it's important that you know those ways of checking for congruency and the three-letter acronyms for them. Well, you can say side, side, side. You can say all three sides are equal, but it's perfectly acceptable to write down in a test by SSS or by RHS. We actually did these for junior cert. I'm not sure if you remember or not. Notation. The shorthand way in maths of writing down that triangles are congruent is like this. I say the triangle ABC, and it's a three-lined equal sign. The triangle ABC is congruent to the triangle CDE. Let's call this ABC, CDE. I shouldn't have used C twice, but that's fine. So that's the notation for congruency. Okay, there's one more thing I want to quickly do before I give you your homework, and that's just to remind you about Pythagoras' theorem. Of course, you've been using this when you did trigonometry, and you've been using it since second year probably. Pythagoras' theorem states that in a right-angled triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides. So in a right-angled triangle, Pythagoras' theorem doesn't work for non-right-angled triangles. In a right-angled triangle, the square of the hypotenuse, the longest side, square of the hypotenuse. Will you be penalised if you misspell it, do you think? You won't. In a right-angled triangle, the square of the hypotenuse is equal to the other two sides squared and added together. The sum of the squares of the other two sides. I'll just do a quick example because I've given you some of these to do for homework. So for example, we want to find the length of AB in the triangle below. So I'm going to draw a triangle. I'm going to make it a right-angled triangle. Like this. There's my right angle. I'm going to say that this is 17. I'm going to give our answer to 2 decimal places. I'm going to get a decimal in my answer. And I'll say that this is 5. And this is AB. So this is the side that I don't know. It's important to identify the hypotenuse. And the hypotenuse is always the longest side, this one over here. And the other two sides, I'm going to call this x because I don't know it. So Pythagoras' theorem tells me that the hypotenuse squared is equal to the unknown side squared and that side squared there. I know the hypotenuse 17 squared is x squared plus 5 squared. So 17 squared minus 5 squared, I'm just bringing that over there, is equal to x squared. And we'll do that in our calculator. 17 squared minus 5 squared gives me 264. 264. So I need to square root both sides to get the value of x. And x is the square root of 264. 2 root 66, but they said 2 decimal places. I said 2 decimal places. 16.25. 16.25. Now, most of what we're doing for the first few classes is kind of revising the junior cert geometry material, but I do think it's important to go over it. So I have a good few questions for you to practice with again this evening, across the weekend. We'll do the corrections of those on Monday and we'll do a little bit more then. And on Tuesday, it looks like everybody's agreed to the Tuesday date for the test. So on Tuesday, we'll have a test on probability. Okay, thank you very much and I will talk to you next week.